Thanks for joining us today. My name's Adrian from the Australian Computer Museum Society. I'm the president here. In December of 2024, we were kind enough to have Ken Cregan reach out to us, and we got to interview him about his time in the Australian IT and communications industry. Ken spoke to us about linking computers such as the PDP-8 here to telephone systems in the 1960s and 1970s. Ken and the company he worked for were pioneers in this in Australia, and me and my colleague Adrian Magni got to speak to him at length, and we present that to you now. So thanks for joining us, and here's Ken Cregan along with Adrian Magni and Adrian Franulovich. Thank you. Okay, so we'll start. So I'm Adrian Franulovich, the president of the Australian Computer Museum Society, and I'm here this morning with my colleague Adrian Magni, here to interview Ken Cregan. Good morning, Ken. How are you today?
Good morning, Adrian. Good morning, Adrian. Yeah, I'm Ken Cregan, and I've been invited here because I've been working in the telecommunications industry pretty well all my life. I'm now 86 years of age, and I started as a young apprentice in the auto industry, and it's quite fitting because I wanted to be an auto electrician because I liked mechanical things like cars, but I also liked the idea of electric principles. So I thought being an auto electrician would be really good. So now that electric vehicles are becoming very modern and popular, I feel quite well placed actually, even though my career took a big diversion. So I started as an apprentice, but moved from being an auto electrician into the general electric fitting and mechanic scenario, and therefore earned my electrician's license at the age of about 19. And fortunately I did well in that, and I won a scholarship to University of New South Wales, which was just moving on from the University of Technology and moving out to Kensington as the new University of New South Wales. So I started there and did electrical engineering, and got my degree in 1964. I did what they called then control, which is a bit like computer science. It was in between communications, mostly about radio communications, that was, and power engineering. Anyway, I did control, which meant using control methodology, particularly servo systems we're learning about there, to control anything. And nowadays that's very important because it can go from rovers on the moon and all sorts of robotics to loom making devices, and to control telephone systems. Now when I first started in telephone systems, well, where I started there, after getting my degree, I went to telephone and electrical industries, because the telephone industry is a beautiful mix of all things electrical. So I worked with telephone and electrical industries, and they were working on making small PABXs, that's a private automatic branch exchange. And I worked with some great people there who taught me a lot about the conventional methods of control of telephone systems, using relays particularly, counting circuits, and different types of switching.
So just to stop you for a second, obviously you said you originally were going into be an auto electrician. How did you make the leap from auto electronics into telephone systems ultimately, or that electronics in that context?
Well, a bit like you were saying at one stage, sometimes things push you, whether you wanted that or not. And I think it was the type of opportunities in the industry, the nature of the work, and I found it a good move to move into telecommunications. So that was a personal decision, which I made, which I'm pleased to have done.
Yep. And what drove that personal decision? Was it because of the job opportunities that were apparent when you were looking? Okay.
Yes.
So there was a lot of jobs.
Well, they didn't have electric vehicles then. A battery was used on your starter motor.
Right.
And that was about all of the lights. Well, of course,
Yep.
so there was a lot more opportunities in telecommunications at that stage.
Because cars would have been substantially more basic in their operations at the time, yeah.
Yes, but I find it quite interesting now, after going through all I've been through, to look at what goes on in the auto electrical industry, which is very elegant and very sophisticated.
Yes.
But I'll come back to telephone and electrical industries, where I was fortunate to learn a lot about what was conventional telecommunications then. They were just moving on from the step-by-step or Strauser equipment to using relay controls of a crossbar switch.
Yep.
Ericsson was the big company in Australia at that moment. They had been employed under contract to manufacture main exchange equipment, and they were manufacturing crossbar switches, which are about this wide, and have about 200 cross points, worked electromagnetically.
Yep.
So I worked with telephone and electrical industries on this. They were taken over by Plessey, the English company.
Right.
And they had lots of opportunities. At the time they were working on mail handling systems.
Okay.
They just completed a system for the Redfern Mail Exchange.
Right.
And there was a big problem with it, in that this mail exchange system used queuing positions to queue up streams of letters and dispatch them to sorting consoles.
Yep.
And they were queued in order, but sometimes the queuing positions would go askew because the number was held on the contacts of relays, and they could get dirty or out of adjustment. And if you got one contact not working properly, the number encoded on the relay would not be translated correctly, and the stream of letters would go to the wrong place.
And when you say a sorting console, do you mean a table with a person that would look at the letters?
Yes. At that stage, literally the letters would be dropped in front of a person who would read the address and code the very new postcode, such as 2119, and they'd code that in, and then off it would go, and that was in a particular type of ultraviolet ink, which would be read by the machines. It couldn't be read like they do now optically. So they would read the encoding on the letter. After a while, they did make machines which could read. Well, they introduced that you could put the postcode number into a particular spot on the envelope, and they gradually developed the technology to be able to read that as the letter came along. So that in effect started the whole mail handling system. And now, of course, that's gone right through, and now electronics has completely replaced letters almost.
Well, I do remember as a kid, I think they started introducing maybe mid-80s the four golden boxes on the envelopes that,
and that was so important because
handwrite, make sure that
the cameras could focus on those and read the numbers, and they only had to read the digits 0 to 9.
Right. And it was, but yeah, prior to that, like you're saying, it was someone literally had an envelope drop in front of them, and then they would read it, and punch that number into the computer to sort them appropriately.
So, telephone and electrical industries had a bit of a problem with the mail handling system, and it was to do with relays and control. So when I joined, they were working on a new system which was going to be for the American post office.
Right.
And they were going to do away with relays. So that they were coming out with boards with the type of thing you have here in your Australian Computer Museum. Things like ferrite core logic, and boards with transistor logic on them. And that was very good, because then we could decode the queue positions, because all this was queued up. And it was quite reliable, and it was quite successful when it went off to the American post office, postal service. So I was lucky there because I got experience in telecommunications and in queuing systems.
Yep.
And in computer control, fairly basic sorts of computers, but computers nonetheless for controlling postal systems.
Yep.
And of course, when you're working in this, you need to test it all. So you start to introduce this sort of technology for the testing as well. So.
And look, to tie it into what we're going to be talking about, obviously what a lot of especially kids won't understand these days is how intrinsic the post office and telecommunications were at the time, and how they were actually basically the same organisations, how most global post offices originally ran telecommunications.
Well, indeed,
systems.
it was the Australian Post Office originally that controlled not only the postal service, but the telephone service in Australia, and that gradually moved on through political movements in deregulating the postal industry. The Australian Post Office, which had a monopoly control of telecommunications, they moved on to become the Australian, or the PMG, Postmaster General, which was intrinsic to them. Then they became the Australian Telecommunications Commission. And then that branched into two parts, the ground-based and the satellite-based. There was a lot of force in the industry to move towards deregulation, because under the Australian Post Office regime, everything was tightly controlled. Only that which was manufactured, usually in England or in some other company like Ericsson's in Sweden. It was all tightly controlled, and a very small number of equipment types, and it was all maintained by technicians from the Australian Post Office and then Telecom.
Now, you brushed on something there that I want to just kind of speak about just briefly, because once again, me being born in 1983, Australia has changed a lot over the last 40 years. Mainly the one thing that I've seen is, and I think a lot of people may have forgotten, just how British Australia was, especially up until maybe the mid-90s, that companies like, you know, Australia Post and the telecommunication service, you know, companies like Qantas, there was a lot of tie-ins to like British, you know.
Well, we are indeed a colony. We're a British colony.
40
That's
years
not
ago,
surprising.
I had an English accent from watching so much, you know,
British television. So, how did you find? Like you mentioned about that, the British influence. How much British influence did you maybe see in those early days compared to the later time, and when did that kind of change that you saw?
There was an enormous British influence. But it was changing because the Australian Post Office were needing to look to other progressive nations for particularly their telecommunications. And Ericsson was prominent, and they had brought out the crossbar switch, as I mentioned before. And also so I may use the terms telecom, Telstra, and somewhat interchangeably because they merged from one to the other. But they needed to get more modern technology, and especially move away from the old Strowger step-by-step equipment. And so they went into contract, or they contracted with Ericsson to provide main exchange equipment. But at that time there was a change in the technology from what the British did to what was happening in other parts of the world. So hence what was happening with Ericsson. It didn't really make much difference to us in the industry. The circuit diagrams were a bit different with different nomenclature, but we handled that quite well. They were still mainly relays and trunking diagrams, and there wasn't really all that much difference from a technology point of view.
Fair enough. So when it comes to crossbar control, obviously that's kind of when you got into the industry. Speak about crossbar control and the company you worked for.
Yes. Well, Telephone Electrical Industries commenced manufacture under license of crossbar switches.
Right.
So I got to learn working there exactly how they worked and how to control them. It's also interesting. You talk about the type of equipment which was especially for subscribers based upon what they did in England.
Yes.
So I need to turn a little towards another type of equipment which was being made, which was telephone equipment.
Yes.
In those days, if you wanted a special type of telephone, they had already started making in England, in the British Post Office, units which had multiple buttons on them.
Yes.
So that you could switch from maybe select 3, 4, 5, 6 lines, or call up a number of other people on extensions. They were smaller versions of what became PABXs, which became automatic switching. But these were very useful in these small organisations. If you had a small office with up to about a dozen people, you didn't need a PABX, which was still a bit large at that time. You wanted one of these so-called keyphone systems. And Telephone Electrical Industries became to make some of these as well. So I learnt about that technology of keyphones. Also, Telecom had a workshop where they too made these specialised push-button phones, but they were fairly limited in their application. Now, I need to move on then. So I was having experience of crossbar switching control at Telephone Electrical Industries, which then became Plessey. There was quite a lot of development for other sort of equipment in the industry, and a particular company was coming to the fore called E.S Rubin. There was a gentleman named Ted Rubin who came to Australia as an immigrant with his family. He was a very progressive businessman. And he formed E.S Rubin Company originally to import equipment from overseas. And he particularly imported push buttons of the type that go into these keyphone systems. And lamp holders and the like. Fairly basic equipment, but important equipment nonetheless. So he would realise that.
So this is the sort of phone that people would have been using at home when you started.
Oh yeah, well that's the very common one. The normal that's called the 800 series telephone.
So the old phone operators, you'd see in old movies, and there would be, I think it was usually a woman with headphones, and you would literally say who you wanted to call, and she would plug.
Yeah, well,
in Australia, or was that earlier?
Yes, there was all that, but particularly this is only good if you've got one phone and one line. If you had 2 lines, straight away you need 2 buttons. Line 1 and line 2.
I just want to demonstrate for our younger viewers the rotary phone. So you'd pick it up, talk in there, and I actually had to explain to my daughter last week. We were on a video call. And I said, it's time to stop, press the hang up button. She said, what does hang up mean? Because in the old days, you would literally hang your phone.
It's interesting.
You can't hang up. But the other thing is, of course, the rotary dial. So pull it there, and then it will roll back. This one's a little bit. But, and I think this would be that this is literally a number of clicks that it then sends down the line. Is that the idea?
And the important thing is it's when you let it go that the actual signalling takes place. And a lot of people didn't realise, and they would turn it round and then push it back faster, which would totally ruin the sequence of numbers being transmitted back.
And so as this was sending those pulses, that was then going into the relays that you're describing to send number of relays
exactly.
to connect.
Those pulses would be read off by a counting circuit, usually in relay form, and sometimes it would be on a rotary switch, where literally those pulses would step it around. If you've dialed 4, it would literally go 1, 2, 3, 4 on the old step-by-step ones, and would set it up to number 4, and then it would move through so that when you did your next digit, it would move to the next layer. And that is technology going back to about 1910 or so. That's how old that type of equipment is.
I always found it unusual that in Australia we chose 000 as our emergency
Rather than
number.
111.
Because 000 indicates that you have to send 3 lots of 10 pulses,
Of course,
which
there's
is the
been-
longest number of pulses
There's
you
big
can
debates
send.
upon that.
Whereas 911 is great because you have to do 1 long pulse so you can't make a mistake, but then 2 of the shortest pulses.
One of the reasons trouble them, 1 is a bit of a troublesome number. Just 1 pulse.
Yes.
Yeah, I can see that.
It can be misread, and in a lot of cases where they found they had difficulties was because they got no pulse at all or 2 pulses.
Right.
And that would probably be one of the reasons. I don't really know why, but as an engineer, I would guess that it troubled some people that they could reliably detect just 1 pulse.
Right.
One. Whereas you can be much more reliable to go the other end and have 10 pulses. So I now have been at Plessey for about 7-8 years or so, and done the American Post Office, and worked on small PABXs and worked on control of crossbar switches, and this industry was developing to make these specialised phone sets with more buttons on them.
Yep.
But another industry was starting too, which were that a lot of banks were wanting to go online.
Yes.
And some of the banks wanted to set up modems in their branches all around Sydney, and be able to transmit financial information into their head office computer. Now, Australian Post Office, of course, aware of this, made sure that they had a suitable modem using tone signalling or voice frequency signalling, and they didn't want anyone to get in on this action. So they made it that they can supply tone signalling modems, which is a box about such size, and you'd connect it, the famous RS-232 interface to a modem, and it'd go out on a telephone line. So no one could make these tone signalling modems, which was technically a very good way to transmit information, which is talking about tone signalling. The modern version of that, which you just show, is a tone signalling DTMF dual tone multi-frequency signalling device.
Does that mean it would send a different tone for each number, or is it
tones
still a number of pulses
out of a group and set them at once?
Right.
And that would be decoded on the modern telephone, which is still how it works with the DTMF signalling. But coming back to what I was saying, Ted Rubin, who'd come out here and looking for opportunities, started importing equipment like push buttons, key holders, terminals, and the like. He had realised that people needed a bigger range of special telephones, particularly companies like money markets. They wanted to have a phone, not just 1 or 2 or 3 or 4 lines. They wanted 60, because they'd have 60 money markets. They'd want to be able to call them with a single push button operation. And more particularly, they wanted to know if a particular money market was calling them back, because they know in a deal that they were on offer for $2 million at 4% or whatever. So this was very important in the financial industry. And E.S Rubin started making this type of equipment. But Ted Rubin also, watching what was happening, saw a possible market for replacing these tone signalling modems. And he thought, now if I can make something equivalent to a tone signalling modem, but he can make it and supply it in competition. So that's where I came in. I got headhunted to join his company to work on, initially, designing some alternative to a tone signalling modem. And it was generally discussed in the industry that one way you could go is don't use tones at all, just use straight DC signalling. There were some complications. One, the electronics, particularly the isolation, and how you might do it. Well, just coming on the market about then was what was called an Opto-Coupler, which are used everywhere now, a very nice way of connecting one circuit to another through optical isolation, where you have a light-emitting diode on one side and a receiver, photoelectric receiver on the other. So I saw an opportunity here, and through Ted Rubin's support, we worked out a design and went down to Melbourne with it and had it approved as so-called DC modem.
Right.
And the other difficulty was it had to work over 2,000 ohms of resistance, which is around about 20 kilometres. So the test was to
it's a long distance.
To have a branch such as at Liverpool to a central computer, and they were commonly in Martin Place in Sydney. So we did that, and it worked, and it could work at whatever speed you wanted. It could work very fast. Actually, they're 134.6 baud, incredibly slow.
I was going to say, so what was the baud rate?
134.6.
134.6, okay.
Which connected to an Olivetti terminal.
Wow.
Of course, that quickly went up to 1,200, 2,400 bits per second. I won't talk about
I understand. We can insert some information on this.
But anyway, the important thing was Ted Rubin and E.S Rubin Company, who was making inroads on telephone equipment and now into the modem market. So that's why I got headhunted from Plessey and joined E.S Rubin. So he was quick to use me and whatever I knew and what experience I had. And he was able to build up his business and had salespeople going all around Australia. He had offices in Sydney, Melbourne, Adelaide, Queensland. And the online industry, as mentioned, was really starting to develop. People were starting to realise we can do a lot more with communications. And also, communications was realised could make money, and it was the beginning of the call centre era. In the call centre era then wasn't even called that. Classified advertising, particularly for newspapers, and also betting, TABs and the like. If you work in telecommunications and you want to control calls and make queues, you learn very quickly an important consideration is what is the value of the call. Now, I also got to work quite a bit in 4 government departments, and some of their calls, and I won't mention the departments particularly because you'll guess, they want the calls to go away. In fact, I even had one client, I said, what's your requirements in telecommunications? And she said, I want all the calls to go away. I don't want any. I said, but you're getting 2,000 a day. And they're all queued up. And she said, I don't want them. So then you work out deliberate delaying tactics for calls. Instead of putting in the 100 lines they should have, you put in 2.
So that
horrible
they get
things
busy
like that.
tones.
That's for another industry was starting to realise there are opportunities and using telecommunications much more. And I was talking about the value of a call, and as you go on, you realise how important this is in the design of your system. So you need to realise what is the real value of a call, and in some situations.
So, speaking of a value of a call, at what point? Because I know that telecom or PMG, whatever, when data calls started to become important, at the time local calls were a fixed cost, but they wanted to capitalise on the fact that all this data was going across the lines, and they wanted to charge per minute or per hour because they're like, well, these aren't voice calls anymore. So at what point did that become an issue, and is that what helped E.S Rubin in their early development?
That really depends upon the advances in technology, where in those days to put in a link from A to B cost a lot of money. Usually it meant a cable.
So that was a leased line.
Whatever, yes, you'd have to put a cable between that point and
physically,
that point. And it would cost a lot of money. But now, just jumping right the other way, it's done by microwave or by satellite. And the costs are spread over more. But going back, originally the cost of a call depended upon the cost of the cable or the transmission link to go from one place to another, and the interface equipment.
Yep.
They were the main costs. And when all this was starting, you would have to count up interface costs and the cost of the cable, how much traffic, how many calls, and try and work out some method of financing this link. But now, since all this, we've gone on now 50, 60 years from all that, we've now established enormous capacity links from one place to another. It's not so much the cost of the link, it's how much can you get out of the person that wants to use it.
So out of interest, when you were putting in these 134.6 baud links, were they a fixed line between location to location, or were you dialing through a PABXs?
These tone signalling modems. If you wanted those, the bank would go to the Australian Post Office or Telecom and say, I need a network of lines from my central hub to Liverpool, to Hornsby, to Croydon. And you usually have about 60 in the network, and you do a deal, or you try to start with, it would all be very carefully regulated exactly what it would cost per mile, then later per kilometre. And so you would lease them from Telecom, the monopoly regulator. That eased the lot. Later on, it came that other people could offer services.
Well, the reason I mention that is because I think a lot of people that would have started in this industry later would be used to being able to just dial for data through a regular local exchange, where they would just dial in a number for a bulletin board or other data service, where they could just dial into a server, whereas this required you to have a
clear line of demarcation between voice and data. To start with, totally separated. The data had to have modems of some type, usually on specially conditioned lines, and you would contract to get them differently. They usually did not go over a switch. There was no switch network then for data lines. Later, a company, Telstra, did start to offer a packet switching type service. So that didn't happen until around about the late 90s and 2000, actually, when they had switched data
full
services.
digital,
Even so, most of the industry built up on an infrastructure from a big firms, particularly a bank. They were the ones who were interested in this. So a lot of it was to do with them.
Well, that's where the money was, literally.
Anyway, and indeed, when you start as a young engineer, and to you it's all about technology. But as you get to an older engineer, it's all about the cost, the value, and the profit. So I can look at it with an entirely different set of eyes now of what the communications industry is. And it's interesting, you can see how it's all evolved. And those questions you asked about what determines the cost are very important questions. And you could write a complete paper on that, what's driving costs. But I'll come back to the things I did, which was that Ted Rubin, building up his firm, he's now brought someone in who knows all about these specialised switching things. By the way, they were called non-switching units because usually the switch was in a PABX. And his units used push-button keys to do the switching. So the switching was intrinsic to the telephone itself. There was no external switch. So they were called non-switching units, which is strictly incorrect. They are switching, but the switching is quite local to the person doing the button switching. And you talked about patching. Well, that's all to do with receptionists and connecting up calls, and that's to do with the history of PABXs and operator consoles. So I won't go into that right now. But I will come back to Ted Rubin because my career is really intrinsically associated with Ted Rubin. What he wanted to do. Because he, in effect, as he said to me once, who else is going to bankroll your ideas as an engineer. Because here I was an engineer and I think this is great, I can work on all this stuff.
Got all these ideas. And
yeah, and you don't think about who's going to pay for it at that stage. You collect
welcome to IT.
You collect a check at the, or money. But he brought it right home to me. He says to me, who's going to bankroll you, what you want to do? And I had to realise, as now as a 30-year-old engineer, he's the only one who's going to put up the money and say, and also invest in these modems and computers. No one else is going to do it unless I find somebody else in another company. So he brought it home to me how important it was. And so he was building up his business at great risk and hard work, I should say. Of course, yeah. And developing up offices around Sydney, Melbourne, Adelaide. And one of his sales representatives in Adelaide came along and said, the Adelaide Advertiser newspaper want a way to connect all their calls more efficiently. And of course, this is a case where the call is worth money.
Yes.
And the only thing you could get was a PABX type device at that moment, which were moving on to crossbar switches. But again, they were controlled by relays. And I told you before, relays are unreliable in a queuing system.
Right.
So they wanted to queue up all the incoming calls.
Right.
And they had 30, but they wanted to expand it to 60 incoming lines. And they had all their agents. And they wanted to queue them up because an agent will get very upset if they're taking too many calls. They want it all queued
distributed
nicely.
Calling,
So they wanted a system which would queue up all their lines, all their calls coming in on lines, and queue up all their agents. Now they call them agents, they just call them operators then. They call them agents. And to connect the first one on the line queue to the first one at the agent queue.
Yes.
And to do it reliably and do it quickly and no blocking. Now, a characteristic of telephone circuits is it's very hard to put in switching to be able to switch everything to everything.
Yes.
It literally is a cross point where you multiply this by that. Well, there's a lot of theory. A fellow named Close worked out how you can work out optimal switching matrices. I won't go into that. That's another session.
Yes.
So the easy way is, if you want to connect 60 lines to 60 agents, you need a 60 by 60 array switch, 3,600 cross points. That's quite a bit.
That's
and you can do it with 2 racks of crossbar switches. Now, I'd already worked out that to queue them, you don't use relays. And coming around just then, and I've got one just here, digital.
Yes.
This is a PDP-11, but they had a smaller one, a PDP-8, which was just ideal.
Which is over there. Yes.
PDP-8.
Right.
It only had 12-bit words. This one has 16, I think. And it only had about 4 expandable to a 8K of memory. But this was enough.
That was
now your phone has got far more than that.
512,000 kilobytes.
But that's all we needed. So I worked out that I could use a computer to control a crossbar switch and offer it to Adelaide newspaper. And I talked about it with Ted Rubin, and he said, well, and because he'd been talking to people in Melbourne, we knew we had to get evaluated by what was then telecom. So we made a prototype and put it all together and went down there. And at the same time, I started building up some staff. And I'd like to mention some of their names. There was a chap named Jean-Claude Barmer. He came from Switzerland, spoke French. He was very good, and he proved to be very good at making printed wiring boards, because eventually we put all this on printed wiring boards. And then I needed help from another engineer, a gentleman named Robert Diamond. He was very helpful, and together he and I worked out a lot of the techniques required to have a computer control a telephone system.
Wow.
So we did that. We worked, correction, I should say, we didn't actually do the program. The first program, which because we put the PDP-8 from digital. I said to them, we want a program to queue this up and this up. And a gentleman there named Alan Williamson said, "Oh, easy, piece of cake." Quite a bit of fun.
Yeah.
Well, you soon get to know programmers. What they call a bit of fun is about 6 months of hard work up till 4 a.m. in the morning.
Wow.
So, and also you learn that the perfect computer program, the perfect one, has only 3 faults.
Yep.
3 faults that are detected in 4 hours. That's the perfect one. So, anyway, so digital equipment through Alan Williamson produced a program to run on a digital PDP-8 computer to control through our interface and wiring, which we did at E.S Rubin Company, to control 2 racks of crossbar switches, which got approved by Telecom Australia in Melbourne.
Yep.
And there's in the Telecom Communications Journal, you can read up about those approval processes.
And that would have, at that time, controlling that equipment using a PDP, which was a perfect kind of reason to control that equipment.
It was a good reason.
It basically was what we now know as a digital, basically, PABX, but it would have, even just for 60 lines, it would have cost an absolute fortune to have a PDP-8 along with the interfaces, but the amount of money it would have...
The computer itself cost around 10,000.
Yes.
Now, I'll talk in dollars, because it's probably pounds in this, but I think it was dollars. About 10,000 for the actual computer, about another 10 or 20 for the interface between it and the
actual... But you're still talking about relays, so it would be an analog call or an analog modem.
The calls were just ordinary telephone calls.
So they were coming...
It would still be switching a wire from my phone to another phone.
Like switching a wire.
So it
was done through a crossbar.
So
it was exactly like old technology.
Yeah.
It's not that my voice is going
exchange
into the computer and then coming back out the other side of the computer, is it? The computer
didn't go through the computer at all. All the computer did was to control the queuing and the connection. It would send out signals to say, I want that cross point there to connect to this cross point here.
It was ultimately acting like the phone operator connecting physical cables. It was just doing it automatically.
If it failed, we had a thing called a routiner where a person would literally patch through. You're talking about actually it was done with switches, but they would select the line and select the because you'd have a display, you'd see all the calls coming in. You'd usually have 2 instances, either an overflow of calls coming in or an overflow of people waiting. So you could usually look one or the other. Typically it'd be more calls coming in, so you'd see them coming in and you'd line them up, and then you'd see the agents coming available, usually one by one, and set them up. We soon discovered the agents would get very cunning, and they would realise if they happened to just pull the plug out for their headset, which queued them, they would go to the bottom of the queue. So one of the nice things about a stored program control computer, when you realise that, we say, we'll put you at the head of the queue. If you do that.
So you reprogram it to move them to the start of the queue. Yeah, wow.
We better not do that. But for a few months, they were getting away with going to the bottom of the queue and not having to handle as many calls. And, of course, the other thing with computers, you can tally up all the statistics. You can get any statistics you want.
I was going to say, so statistics
how many agents have you got? How long are they taking per call? How many are they servicing? How many lines are coming in? How long are they waiting?
Because I think that's a really important part here. And I think, once again, I've kind of grown up, I believe, in this kind of unicorn phase. I've grown up on both sides, where there was computing, no computing, mobile phones, no mobile phones. Telephones were the major form of communications to now, although we use our phones all of the time, no one actually picks up the phone to talk to people. Most of it is done through text messaging, through online messaging, through email, whereas you're talking about a time where the only form of communications, and the reason it was so important, was you literally had one line to your customers, and that was a telephone handset.
There's a complete separation between voice communications and data. And now we merged them, which maybe I'll just say, realising all this around about 1975, I realised the key was telecommunications. So I formed a company with that name.
Wow.
And after, just to cut a fairly long story short, and we did that that worked very successfully, that system for Adelaide Advertiser newspaper.
Yeah.
Unfortunately, Ted Rubin, who was a pillar of telecommunications and should be referred to as such for what he did, he passed away about 1983. And just before that, because we went through developing all these, we realised the systems were becoming so complex. People needed consultants.
Right.
Also, there was by now, the rest of the world had realised that computers could control telephone systems very well. And they're going to much more advanced switching than the crossbar. They're using pulse code modulation, bandwidth modulation, much more elegant methods of switching than space division. So Rubin was facing a lot of competition, and he realised that one of the opportunities was in consulting to help people. How do you understand and install this equipment?
So were you then consulting on alternative products that weren't from E.S Rubin? Because obviously at the beginning you would have been probably...
In the early 80s, when all these changes were always happening rapidly, Ted Rubin said to me, how would you feel about doing consulting? And I had to say to him, look, Ted, this is something I've got in mind. So we amicably decided I would go off and do consulting.
Right.
He would continue. Now, in what he was doing, now, as I said, he was always looking for new opportunities, and he found a new opportunity in boating, in the navigational aids used for the people in the yachting and boating industry. So he took over a company called Prouds Marine, and it was happily going along with that. I should also mention other people in his organisation, particularly Eric Rubin, his son, who was of great support because he was behind all the ordering of the equipment, and to do with the marketing and selling. So, because you got to have 3 or 4 in a partnership team to make all this work. The engineer is just the guy which puts it together, but the key people are the ones who get the orders, the salespeople, and the people who can market it, and also then when you've got to actually make it, to help making it. So I had the support also of E.S Rubin Manufacturing, the people who made these modems and made the
and it was all made.
Phones.
It was all made.
We made it all at Artarmon.
Yep.
Yes, except the digital equipment which came from DEC in the United States.
Well, Massachusetts, and it would have been sent here.
Yes, that's right. So it would turn up, and we'd connect the two together and test them all out.
Yep.
So that was a good way of going, and it went well. I just wanted to mention there that I eventually moved on up to about 12 years at Rubin's to form my own company called Telecommunications to do consulting.
Right. And
it was a good time because all these new technologies were coming in. But to finish the story when I was at E.S Rubin Company, that system with the Adelaide Advertiser newspaper went particularly well.
Yeah.
And you could realise that I remember when it was first switched over and you could hear click, 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 all the crossbar switches.
Relays going,
and every one of those meant about $10 coming in.
Yeah.
Then there were service organisations, NRMA, they wanted one.
Yep.
So we made one for them. Their first queuing system was made by E.S Rubin Company. Then all the road service organisations wanted one, RAA, the people there. All of them.
DMR.
RACV. And I noticed the magnetic tape. Because each time we made one, we'd add something new to it, like for the NRMA. Because while you're waiting in the queue, you want something to tell you, hang on, please wait, we appreciate your call. We'll deal with it as quick as we can. So you'd have recorded voice announcements intercepting the call. So the programs are becoming more complicated because you're now putting in other queues. And then you discover when you've got some sort of money market operation. Because these key phones, I mentioned about dealers. Well, of course, the dealers wanted one of these. So we made some very specialised systems for some big dealer companies, queuing calls and being able to do quite interesting things with the way you control calls. Like having not just one queue, you have multiple queues. You You know, your dealers that are bringing in millions of dollars, they're on their special priority queue, and your special agents, and you're hooking up your special people with your special agents. So that was all able to be done. And I should mention, because of all these things, we were growing and becoming more successful, I was able to recruit more people, and particularly Heather Hallinan, who did software, and Con Ustenbasidis, who are very good on writing software. Heather went on to do the software for the Hong Kong Jockey Club.
Oh, wow.
Really been, really
I've
worth
been
a
there
lot
for
of money.
lunch, I think. So.
And after we were doing these systems for service organisations, the TABs wanted in on the deal because I mentioned the value of a call.
Yes, of course.
Well, TABs, they're not talking about $5, $10 the value of a call, they're talking about $100.
Yes.
The value of a call. And they told us.
So spending $10,000, $20,000, $30,000 on a system was nothing in comparison to the value return.
Well, they
that
told
could have
us
got.
if the system failed during a race, it would cost them at the time $1 million per race.
Yes.
So everything was backed up. By this time, I mentioned we moved on. The PDP-8s, good though they were a bit big, a bit expensive. And microcontrollers were coming out, the 68,000, 6809 series. So we found we could get a nice little card with Motorola 6809 processor, complete with about 64K RAM, which was good for us. And we could get that, and it was only a fifth the cost.
Of course, yeah.
And so we built that. And then another engineer joined me, whom I'll mention, Lindsay Holt.
Right.
He was good on doing interface and working with microprocessors. Lindsay all these people that I've mentioned went on to really good jobs. And another one, Peter McConnell, he went to head up Honeywell's digital
quite a large company.
Industry.
Yep.
Yeah. And Heather went to the Hong Kong Jockey Club. Condos to Bacidas, I think, went to British Telecom. All moving on with their careers in that and leading up to executive positions.
Yep.
Lindsay Holt was headhunted by an Australian defence organisation and worked on some very hush-hush, over-the-radar type defence equipment. So that's another story. So in this that I'm describing, I'm also trying to talk about the people.
No, I understand,
these engineers, because I was just the one who happened to be at the right place at the right time to engage and recruit these people.
Yeah.
And it's these people who really did
push the
brilliant design work.
Yeah.
For example, in the system we did for the South Australia TAB, we needed a solid state switch. Now we could have looked at time division type switching, very complex, but there was coming out then from Signetics a cross-point array that was solid state.
Wow.
Quite small, quite economical.
And
the only problem with...
the maintenance would have been significantly lower and the power use...
Well, for the TAB we wanted not just 60 lines, I think it was 144 lines to 144 agents. And when the type of... That was new, it was new at the time and quite advanced, but it was only one leg switching, not balanced. Now, if you know something about telecommunications, you always use two wires, a pair, and you keep them as close together to have a minimum area it contains, so you don't get magnetic influences in them.
Okay.
So it's important to have it all balanced. So if there's some stray inductive field somewhere, it's going to affect one and the other, usually the opposite direction, and cancels out. But this was a switch array that was just switching one leg. So when you showed the telephone before, it's got two wires in the pair, an A and a B, or sometimes positive and negative.
So are you saying something like that all the phones would have a common ground?
Exactly. Well, that's where you've got to be very careful. Telecommunications and ground are an anathema to each other. Right. You want to keep ground away from a signaling circuit. Ground aside from potentially causing an electric shock and introducing, people don't realise sometimes the ground here can be 1,000 volts different to the ground 3 kilometres away.
Right. Apparently, just one of our members here, Murray, he used to work for Telecom Australia, and apparently where phone booths were on train stations, because the trains, when they would roll in, would put all this energy into ground, they would actually cause the phones to blow up on the station, because the actual ground lines would actually take all of this voltage from the DC deceleration of the train.
There was something very wrong.
Yes.
It shouldn't have done it, of course.
But they had to put in...
But it shows you, yes, and the study of interference in lines and the effects of balance is a specialised field in itself, and it can be very controversial. A lot of people say, oh, you must have single point grounding for this, and others say, no, you've got to have multiple point grounding. Well, there's a place for both, and it takes you about a year of study to really understand that. So anyway, Lindsay Holt was an expert in this, because we had to take this single point one leg switching and make it so that it didn't have any crosstalk. So what you've got to do, you've got to use coaxial cable for your wire, and the earthing has got to be very carefully controlled. And as I said, you've got to know the difference between single point and multiple point grounding, which he did. And so in this case, it was single point grounding. So every cable in on coaxial, the grounding had to go back to a single point, so that you couldn't get any linkage of one circuit to another. Otherwise, you get crosstalk on the whole thing.
And when you say crosstalk, is that literally I could hear him talking on his phone?
Well, it's a term used to describe a multiplicity of sins in technical circuits. Usually, it just means one speech circuit is interfering with another, and you can hear it. But you can also pick up the signalling. We were talking about how you have a signalling circuit separate from the voice, and sometimes it's embedded. The signalling is embedded. You've got to make sure that signalling circuit doesn't interfere. With the
so it's at a different hertz rating, so it doesn't interfere with the audio.
It's in these areas that you are really tested with how much you learned at university about Maxwell's laws and pick up of magnetic interference.
Well, magnetic interference, I remember as a kid, I learnt about it very early, because when I would call my grandmother, the lines, she lives in Birrong, she's still in Birrong, the lines weren't as good quality as where we were in the Ingleburn Exchange. So I think Ingleburn Exchange had already moved into a, crossbar or whatever, or a newer solid state system, whereas her exchange was still on crossbar, and you would hear these noise. But I always remember, if I was on the phone to her when the tones were being played for energy, so for when the street lights turned on or when the hot water service would turn on, all the actual fluorescent lights in her house would play the tones, and I could hear them across the phone line. As a kid, I could hear that.
You need to go and have a look at her place.
Yeah, and I was like, why can I hear this? And I found out years later why you could hear it. It's to do
with the earthing of it and the coupling of all the circuits. And also, a lot of people don't realise that a switch generates, when you first switch it on, generates a whole spectrum of frequencies, right up into the radio range. In fact, in some cases, in some very rudimentary radio transmissions, they actually use a spark, and the oscillations you get, and it will transmit a signal. So every time you get a very
AM radio,
rapid,
isn't it? It's AM radio, isn't it? How it works, basically.
No,
you're just modulating. I thought you were modulating.
The very earliest ones, it was literally a spark
transmission,
or short wave
that was
transmission.
When they used it, the very early ship to shore.
Was that if I had a
that's
1
right,
inch
spark
gap,
transmission,
and you have a 1 inch gap, that they'll resonate and
that's
you can
right.
pick it up, and then
that's how they discovered
it. You would move it apart a bit. So you'd have a 1.5 inch gap, and this was supposed to be different
change
channels.
the frequency, yeah, exactly. So that's taking you way back to that 1880s or something. But all these are old technologies and and what people knew about them, you have to carry forward into what is happening in the computer age. And that's been happening more and more as they, because when you get to these very high frequencies, inductors become capacitors and capacitors become inductors. You get some strange phenomena. Anyway, I'm drifting off the point, which is Lindsay Holt was a true engineer who understood things like Fourier analysis, Laplace transforms, and all these things. And so he could work out all the really elegant parts of what you needed to do.
And just really quickly, Fourier transform is something like if I play a 2-note chord on a piano, say A and C, then I've got the A and then I've got the C, and it comes out as a wiggly wave. And that you can essentially pull out the 2 notes.
Yes, if you've got a wiggly wave,
that you
Fourier
can get back the original
you can
2 notes.
See that is made up of a series of fundamental tones.
And it's a way that you would do that, but with radio, to pull out all of the signals from a grouped multiplex.
In actual fact, engineers never actually use Fourier transforms. It's one of those things that you have to know about the fundamental theory behind them. But generally, having an idea about the theory and what's going on, you concentrate more on the methodologies to make sure you don't get into trouble. Like I was saying with this single point grounding, we knew that we could run into nasty problems based upon all the complex theories, but we were fairly practical engineers. We just wanted to make a computer controller telephone system. we didn't want to threaten Marconi or anything like that.
Of course.
So we were concerned to know what the principles and I was lucky that I had a really good team who understood the principles particularly well. And so we made it work, the system for the South Australia TAB. And as I say, that things were moving on then. The whole technology was changing. Voice was starting to get integrated with the data. They were wanting to switch data as well as voice because the internet was starting to come. People were starting to want to use these modems to connect
boards
on switch lines. So you'd have the switch line modems coming complete circle to what you were saying. And so people are now getting their Osborne computer or their IBM computer and wanting their modem going at about, what were they?
1200 BPS.
56 28.
Yeah, well, they went up to 56K,
And so they're wanting to transmit that. So all this was happening. So it was a good time for me to go into the consulting business because these firms were wanting to use all these things, and particularly they were like the NRMA, like they wanted a new system. And in telecommunications, I said, what sort of system do you want? And maybe at the beginning I said maybe we could make something for you, and they said to me, what if you go under a bus? We're not going to want to buy stuff from you. We can buy this from the United States now, from Nortel, for example, coming out with some beautiful, beautiful computer control equipment with solid state or packet type switching, really nice stuff. So they said, we want to buy something. Can you help us buy it? So I found a good niche then, meeting with clients and working out what they needed, and going through
the process,
survey of what they need, and then I got a lot of work with government departments because they want to know the 3 different solutions to something, what it each costs, what's the present equivalent or present worth. So you quickly have to learn some financial things, which all engineers should learn. I was talking about the value of a call. So you need to know those things, and then you present your report with the different alternatives and a recommendation. And hopefully they may accept your recommendation, but sometimes they don't. They want to do something. In fact, one of the key roles I discovered, this is digressing a bit, as a consultant, you've got to determine why the client is really engaged you. Now, it's good if they've engaged you because of your technical knowledge.
Yeah.
You may actually help them to buy the best equipment.
It's bad
but
if they just want a
sometimes they
second
don't.
quote.
You discover they're having a big argument
Yes.
with their computer division, right, versus their admin division.
Yeah.
And they want you to sort out this argument between the two. So you've got to figure out what's really going on. And sometimes they've got a hidden agenda which you don't discover till fairly late. They've already decided they want to do that. And it doesn't matter what you do.
No, they literally just want you to be put into a report to say to someone else that you got a second opinion and that you still decided for the one that you chose for. Yeah.
What's the joke? Before I write my independent report, what would you like it to say?
So that's another story about what happens in the consulting role.
Yeah.
And I had quite a number of clients, especially government departments, even radio stations, Macquarie Broadcasting,
Nice.
2GB.
Yep.
Because something I didn't mention was in broadcasting, it's very important they can talk to a client on the phone.
Yes.
And E.S Rubin was probably the first company before I joined them to make a specialised phone system.
Well, talkback radio.
Could be interfaced to a radio station.
Yeah.
And that went on for people like John Laws who used this sort of equipment. But later on, intriguingly, in my own company, Telecommunications, I got engaged by, again, it was Macquarie Broadcasting, and they wanted this to go through their PABX system. So the trouble with the specialised telephone, you could only patch that call that came in on that line to that unit. But with the PABX, you could patch any line through the interface. So that was something I was able to do later on, and that was
now. I noticed that you'd brought a number of drawings with you from E.S Rubin. Do you want to quickly explain what these drawings are? I'm guessing that they're of the interface
well, something
cards.
particular I should refer you to is the Telecom Journal of Australia, which fits in very well with the Australian Computer Museum and its society, because I'm sure you would have pretty well every one of these.
We possibly would,
and,
yes.
This is the Volume 25, number 3 from 1975. And it literally describes from the telecom point of view their evaluation of these systems that I was talking about, including the Rubin system.
Oh, cool.
Actually, our system was submitted about 73 or 74, and they're talking here about the one for NRMA. But Ian Bolte, who was a gentleman I was involved with in Telecom Australia at the time, he wrote an excellent article here where he reviewed systems, PABX systems from Amalgamated Wireless. They submitted the Hitachi. Ericsson, their ARD 520. Siemens, their ESK 730. Standard telephones and cables. But then he goes on to these queuing systems came to be called automatic call distributors.
Because I think it's important for people to remember that this document, these being issued by someone like Telecom, would have been educating people in that industry because there was no website to look at. There was no. These were industry.
This is a society, just like the Australian Computer Museum Society, and it's valuable. And these societies are very important because they collect together this which could otherwise be lost. And in telecommunications, we would all make sure we subscribe to this.
Absolutely.
Unfortunately, it doesn't continue in the same form at the moment.
No.
It merged with the Australian Computer Society. And unfortunately, they did not keep up this tradition.
Well, it would have been very interesting because you actually saw how problems were being resolved through the ingenuity of companies like E.S Rubin and people like yourself. People could have understandably gone, well, I've got this problem, what's the solution for my client? And then they see that you've actually solved the problem through this particular product which you're producing, and then you would have attracted more sales and more clients.
That's true.
It's it's wild for someone my age to think like that, because now everything is just in your face all of the time. You wake up in the morning, your phone's got a whole bunch of notifications. You know instantaneously of everything that's happening everywhere, whereas you actually had to go looking for this stuff before, and you had to be very socially engaged to actually understand.
Well, that's what happened with computers and communications. That's why I thought telecommunications described it so well. But the new version of that is 4 letters, VoIP, voice over IP, and it was with packetization that actually allowed to the real merging of voice.
I got into
and
VoIP
data.
very early on. Like I put my business onto my own company in 2005, which made us a very, very early adopter for VoIP, and it was incredibly cheap compared to regular digital phones. But what I did was I worked out a balance. We got this great package at the time from originally Telstra, of a 2-line ISDN service for, I think it was $75 a month. We got 2 business digital lines with 100 number, with 100 call number range. So I got a DID range of 100 numbers, which was a bit crazy because there was only 4 of us in the office. But I worked out that I could have all the calls incoming across the 2 digital lines, but all of our outbound calls would go across VoIP to save money, because although the ISDN line was very cheap for having multiple lines, it was very expensive to make digital outbound calls. So we would route all the calls out over our analog line or out of a VoIP service. But then Optus came to us in, I think it was 2007 or 8, and said, we've got this deal, we'll give you 10 lines on a primary rate interface, and we're going to give that to you for $199 a month. So we had 10 inbound lines plus our original analog line, which was our ADSL service. So we had 11 lines for, at that time, I think about 7 employees.
And the irony is you don't get 11 lines on your iPhone, do you?
No, you don't. So I had 11 lines inbound, 11 lines inbound. But what we did was that effectively amortized it to $20 a line, and then all of our calls were still going out over VoIP. So Optus thought, well, we'll sell this service to you for a very cheap price at $20 a line, because ultimately we're going to get all of our money back from you making calls out of our service. But the only calls that went out over the Optus service were our local calls, because they were untimed, and 1-800 calls, and then everything else to mobile went out across the VoIP service, and we saved a fortune. And I actually put it
beautifully summarised.
So that was least cost routing, as it's known. But I manually did least cost routing.
And you played the game well, because those suppliers are out to try to manipulate you to do it their way. That's and you worked out another way.
I worked out a way around it. And look, I loved finding little tricks like that, because I know that...
Well, that's a whole industry, you know, where some of the consultants, that was their game, business was to find the least cost routing method. And sometimes in the clients, that's what they would say to you in their network. How can we do it? And we would use tricks like that within the PABX. So the PABX would select you to a least cost route.
And look, sometimes phone systems didn't work in your favour. Like you mentioned earlier about how the agents would pull their handset or whatever to drop to the bottom of the queue.
They learned tricks real quick.
Absolutely. And when you would have put in your systems like the PDP, straight away you would have actually started having the statistics back going, hang on, why is that agent only taking 2 calls a day or 5 calls a day, whatever it was, but this agent's taking 20. So it would have been very easy to hide away in your cubicle at that time on a phone call, and no one would necessarily know that you weren't on a call, because there was nothing to suggest. You could have sat there literally with the phone to your ear talking with no one on the other end of the line, and your boss wouldn't have known.
You're getting into a dangerous area now with cameras and artificial intelligence.
Exactly. So, but now all of our calls are recorded, all of the statistics are made, and the other great thing would have been when caller ID came in, all of these organisations actually started to know who the callers were, and that was important because that expedited knowing who problems callers were and being able to block callers.
Well, they do this,
and
they have a term called vexatious caller.
Yeah,
and if you're not careful, you'll end up on the vexatious caller list. I'm sure that I'm on that list. To get the absolute worst service.
Yes. Well, I remember I learned about PABXs really early, weirdly. My dad worked in a mine and they had not only a PDP-11 on site, but this massive, I think it was a telecom commander system, which
that's another example of a keyphone system.
Yeah, exactly.
That's just a modern
local
development of the push-button phone system.
Exactly. So
Rubens were making.
I was just infatuated, and I worked out very early from his office that every time he moved his phone extension at the office, which was a 4-digit number, which was quite crazy at that time in the 80s, if his phone extension, it used to be 4101 was his phone extension, and when he would move, if they patched his phone along, or if they didn't and he got a new phone extension, his number would be 464041 because the last 4 digits were actually, they owned a 10,000 digit or 100 digit range at the mine site. I think it was a 1,000 digit range because everyone had their own direct in-dial. And I worked out that his extension matched the telephone number on the street, which was a very common thing telecom used to do at the time. So when I went to high school, I worked out very quickly that the extensions at the high school, if I took the last 2 digits and transposed them onto the school's public number, I could call anyone's phone in the school directly, knowing their 3-digit extension.
Maybe didn't realise it themselves.
No, I don't think they did. But then, and I used to play with that a bit too, much to people's chagrin. But I remember in 2005 or 6, I worked for Apple for a while and I owned my own Apple centre or dealership, and one day we were in a training centre at Apple and there was a list of everyone's phone extensions in Apple Australia, and I went and I got out my diary and I wrote down everyone's name that I thought would be important in the future, and I took down their extension and I worked out very quickly I could ring these people directly by changing Apple's last 2 digits or 3 digits on their number. And one day I had this very important, issue. We were repairing a computer for a customer and something went horribly wrong, and I could not get through the IVR exchange at Apple to speak to who I needed to speak to. Yeah. So I rang the direct number that I'd taken down, and instantly I get onto the person I need to speak to. And they're just like,
it shows a lot of ingenuity.
Adrian, how did you get through on this number? How did you ring my phone directly? And I said, that's not important now. What's important is our client. And I told this story years later to Apple Australia. They were doing a recording, and I told this story probably in 2015. And I just remember it being a great it was my little homage to, I guess, Steve Jobs in a way, because I'd hacked the phone system to basically bypass all of this structure in place to actually put me through all of this call queuing and traffic management, and I just bypassed everyone.
With some government departments and see if it can be applied.
I can tell you right now, I still to this day...
Money is concerned.
Yeah. Well, I recently rewrote our accounting system at the office. I wrote the accounting package that we used 25 years ago. And, not that long ago, I realised that, hang on a second, now that we're full VoIP system, why can't I use the clip information, the caller ID presentation, to actually bring up the person, because we've got over 40,000 clients. I was like, well, hang on, we're getting dozens, if not potentially up to 100 calls a day. Why can't I connect that data on the caller line identification to their record in our system? So immediately I know who it is, if they've got equipment with us, if they've been a recent client, history of their account. Good. So now as soon as someone calls into my office, we answer and we go, with blah, 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 and we say, oh, am I speaking to Chris? And they'll go, oh, how did you know that? And it's like, well, because you're calling off your phone, which is your number.
I can tell you that Ted Rubin would have loved you.
Yeah.
he would have put you in his sales force, head of sales, and you would have been going all around the country and overseas.
I would have loved that.
Yeah, and you would be coming up with ideas like this and discussing it with him, because he was so keen on having a repertory dialer, which is exactly the lines you're talking about, so that with one button he could call up any of the people he wanted. And it was a punch card type thing, but he would have loved your ideas because you.
But what I don't understand is why I call someone like, American Express, who I mentioned before, or any bank. They ask me to punch in my customer number or phone number or, any kind of. Half the time when you get transferred to an agent, they haven't received the information. They ask you for it again. Yeah. Clearly, they know my telephone number. They know that that's attached to... Well, a good call
centre will hold that and transfer it onto the modem.
So I wonder why... Like, I can appreciate with privacy you need to verify that the person on the end of the phone is the person you're expecting, but why they don't use that to understand who I am and say, am I speaking to Adrian?
And they don't do it the other way. Yeah. You have to prove to them who you are, but they get away with not having to prove to you who they are.
That's a big problem with scams at the moment. So many, and funny enough, the worst is actually the Australian government. Whenever I get a call from the ATO, they can't give me any information about who I am.
Privacy, they won't let you. But you've got to tell them.
But they're calling from a block number.
The name of your dog and what time of
mother's
the day
maiden name, all of that information. And the
what
amount
sort
of
of chocolates your wife likes.
The amount of times I've said to them, look, I can't continue this call because I can't verify who you are. And they're like, well, we can't give you a scrap of information until you verify. I'm like, look, can you at least tell me while you're calling?
They don't listen. They don't want to hear.
It's funny how telecommunications it's still so intrinsic to our lives, and it's probably the least secure form of communication now, but we've kind of given up on it because we're so used to pushing.
It all depends upon the value of the call, but now the value of the call is related to a scam, and it's your money in your account which is going out by the thousands. So it's really extremely
it's actually it's a funny way of looking at it, but you're absolutely right. Whereas, say, someone calling into the TAB once upon a time was worth $100 a phone call, which was profit to them. Now, most calls are actually considered a cost to a business. That's why most call centres have actually been offshored all into one. And now the only thing that was holding the clients there was, I don't want to lose my email address. And guess what? The email is now held by a third party.
They didn't value that aspect of the.
Clearly, someone's made a bad decision, and they're going to lose a lot of clients.
Yeah.
And now's a very good point to say that Exetel is a large sponsor of the ACMS, who provides us internet to the ACMS. So please contact us if you'd like to become an Exetel client.
So we start to wrap this
I think we should wrap it up. I think we've.
I've enjoyed talking to you.
Yeah. Thank you for coming along today.
I think your insight into the whole industry is quite profound.
Yeah.
And so it's yours, Adrian. So thank you for the opportunity of coming along to the Australian Computer Museum, the Society.
Yeah.
And
would you know
I think it's a very valuable service that you do here.
Oh, and look, it's really valuable for you to come along today and talk about this, because I think it's really easy to forget just how much money was in telecommunications. And to be honest, telecommunications spawned the entire digital computing.
It did, and the people that I was lucky to have work for me and my team, they deserve recognition.
Absolutely.
And often it slips by, and they don't get remembered or identified.
And certainly, when it comes to digital, it was companies like AT&T or Bell Laboratories that drove the manufacture of the chips and the actual the abilities for companies like digital
seed type company.
That's correct. So they basically made the building blocks that allowed companies like digital to form, but then in turn, digital allowed telecommunications companies to actually grow infinitely as well through these very smart systems.
And it's interesting to look back and see what little span of time each of these particular entities.
Yes.
They seem to go for a long while, but actually it's probably only 5-10 years that they've had their glow.
Yes.
And bring what they have. And the same is true of E.S Rubin Company.
Yeah.
They had their glow.
Yeah.
And I think it's good to remember Ted Rubin.
Yes.
Who
he
often,
sounds like a very smart guy.
Absolutely. And often not appreciated for what he really was trying to do.
Yeah.
To develop the industry.
Yeah.
Of course, he had to make a profit, and very necessary. I think in the end, having to bankroll us team of engineers, I'm not sure he made all that money.
It's important to remember, though.
But he gave us a career. We got to learn more about engineering and about single point ground.
Yeah. Well, you didn't just kind of work in an industry. You actually formed an industry because you actually created an industry that didn't exist. Yeah. So it's important to kind of notice that pioneering
Joe
aspect.
Van Workum, I see here there in your museum about the looms.
Yes.
He went on to design looming machines that were computer controlled in Australia. And on that, I want to say how valuable are our Australian engineers.
Yeah.
And I think from what we did, we were the first company in Australia to produce a computer to control a telephone system.
Yep.
And in many ways, we're at least equal to the rest of the world, and in some ways ahead. And this applies to everything, and it applies.
But I think we should just.
Well, Adrian, I'd like to thank you very much for the opportunity to come and talk with you.
No, thank you for coming today.
It's been really
with you, Adrian.
So thank you. I've actually learned a lot just from hearing you.
We hope you found your time with Ken Cregan as interesting as we did. Please remember that you can sponsor the ACMS by donating online at acms.org.au. You can either give a tax-deductible donation, you can sign up and give a small monthly donation to the charity, or you can become a member and come and see the ACMS here in Croydon in Sydney. We hope to see you soon. Thank you.
From hearing you today.
Yeah, and I think it'll be a really great education tool to kind of tie in with the actual museum exhibits, because look, we've got a lot of these products that you talked about, the digital computers. The PDP-8 is just over to our side.
Let's have a look at that.
Yeah, and we've got a lot of the actual process control equipment also here as well, which is what the PDPs were famous for. But telecommunications, as you probably have understood, it's actually a fascination of mine and something that I've always been heavily involved with. I've owned a PABX personally. I've got a PABX in my house for the last 15, 20 years. Being able to call between the kitchen and my bedroom, even though I live on my own, it's very important. But hey, you've got to have your little niche in life and your little hobbies. So look, thank you so much for coming along and giving us this education.
Thank you for the opportunity.
Yeah, no.
Thank you very much.
Thank you everyone for watching.
And to the Australian Computer Museum Society.
No, thank you.